Hi, class. This is Mr. Hart. In this podcast, I want to go over some of the topics we covered in week 2 of the solar system. And the first thing we covered was the formation of the solar system. So, we want to look in detail about how the solar system came to be and how it formed and why the planets are in the places they are. And just like any other star, our sun formed from a nebula. And as that nebula came together, they eventually had enough gravitational pull that the nuclear fusion process was able to start, and our sun formed in the center. Then what happened is these large clumps around the outside, all this leftover material, kind of went whirling around the edge, and as they went whirling around, it started to collect in the other material until we eventually get the planets that we see today. They become larger and larger and larger and kind of clear their orbits. And there's a video that we watched on YouTube that I highly recommend going and watching for yourself at this link that really gives a good visualization of this process of the sun forming and then the planets collecting the leftover material and becoming what we see today in the solar system. And so we know the solar system is the way it is because we can look at how other solar systems form and we can look at some key features of our solar system. In particular, these two ones really give us big clues. First of all the planets lie in nearly the same plane or flat disk-like region. So that means that early on, the nebula had to compress at some point into some type of plane, probably near when nuclear fusion started to occur, sometime before that. We also know that all the planets orbit in the same direction around the sun, which tells us we have some type of initial movement, kind of like a regular galaxy around the center. Our solar system moved around the sun. And so that material was initially moving around before it ever formed into the planets. And then as it was moving, it collected the leftover material and then formed into the planets we see today. So again, highly recommend this video. It really gives a good visualization of what happened. Okay? But now we want to start going deeper into the actual parts of our solar system. Okay? So particularly we want to look at the planets and some of the properties of the planets. This table gives us some interesting information about our planets, like their average distance from the sun, the length of day, the length of their years, right? A day, how long it takes to rotate on its axis. A year, how long it takes to revolve around the sun. But you don't have to memorize this table, but I want you to look at it for a second and kind of get a good picture of some of the different features of the different planets. In particular, looking at the distances. Okay, notice how the first 4 planets are all very close to the sun and the other 4 are very, very far away. Okay, the first 4 planets have relatively long rotational periods, and the outer 4 have very short days. And then the years are very short for the inner planets, and then the years are very long for the outer planets. So as you just look over that data, it kind of makes some mental notes about each one of those features. Okay, but let's look at each planet individually, and we'll start out with the inner planets. So the inner planets are the first 4 planets closest to the sun. They're called the inner planets because they're inside the asteroid belt. We'll look at that in a second, but there's an asteroid belt between Mars and Jupiter. Okay, and so that's kind of our boundary line where we make that distinction. So everything inside that asteroid belt is an inner planet. Everything outside that asteroid belt is an outer planet. Okay, so we'll look at Mercury. Okay, Mercury is the first planet. It's the closest to the sun. It is solid and covered with craters, has almost no atmosphere, and it is the smallest planet. And if you look at the word Mercury in Roman mythology, it's the messenger god, which makes sense to the Romans at the time because Mercury looks like it's the fastest moving planet in the sky to the naked eye. And so they had this vision of the fast-moving, messenger for the gods, and so they named the planet Mercury. And so if we look at each one of these features, it's very solid and covered with craters, mostly because sometime early in the early formation of this solar system, as a lot of material was flowing into the sun, a lot of it was bumping into Mercury on its way in, which is why it's covered so much with craters. It has no atmosphere because it's just so close to the sun, anything would just kind of vaporize. And it's just small just because of where it's at. Okay. And then we have Venus. Okay. Venus is the third smallest planet. It is about 3/4 the size of Earth. The surface of Venus is very rocky and very hot. It does have an atmosphere. And in fact, the atmosphere is so thick that when you actually look at pictures, you're not actually looking at the surface, you're actually looking at the clouds in the atmosphere. Okay, and that atmosphere is so dense that it actually traps in the heat, kind of like a super greenhouse effect, if you will. And so Venus is actually hotter than Mercury just because of this very thick atmosphere. And it's not a nice, oxygen atmosphere. This is very thick, dense materials. You're talking very poisonous materials you don't want to breathe in. But they trap in all that heat and keep Venus very hot. It's also the only planet which has a day longer than its year, which is quite kind of interesting. It rotates slower than it takes to revolve around the sun. Okay, then there's good old Earth. You should be pretty familiar with this planet, I hope. It's the only planet known to have liquid water at the moment. Its atmosphere contains oxygen. It's the only planet to contain life. It's the fourth smallest planet, and it has one moon. Okay, and again, when we think of moon, in this class, it's not going to be specifically just our moon, but a moon is just any object that revolves around a planet. Okay, I won't go too much detail into Earth because that's for the rest of the class. All right, then we have Mars. So Mars, the red planet. In Roman mythology, Mars was the god of war, and because of its nice red glow in the sky, they associate it with blood and war and courage and all those things, and so they thought it was Mars planet, the god of war. So if you look at Mars, though, it has a very thin atmosphere. It's mostly carbon dioxide. It also has two moons, okay, whereas we only have one. It's called the red planet because it looks red in the sky, and it mostly has dry desert, craters, canyons, and volcanoes. So Mars is a very, very interesting planet to Earth. And that's because Earth and Mars are so similar in their features and characteristics and similar in distances and size, but Mars is not hospitable at all and Earth is. Just that small variation in distance from the sun cause tremendously different outcomes. One planet has liquid water and abundant life, whereas Mars is dry and dead, basically. And so it's believed at one point Mars may have been actually very close to Earth, may have had liquid water, which would account for the canyons and such. They may have had an oxygen-rich atmosphere, but eventually went into carbon dioxide. There's still a lot of speculation about it, but it's just interesting that if Mars had been a little bit closer to the sun, we may have had two hospitable planets. We may have had extraterrestrial life on Mars. And so Mars is very interesting to study, very interesting to look at its history, and we'll go a little bit more into detail about it soon. But for now, just kind of memorize these specific facts. One other thing I want you to remember is Mars has a lot of craters. That's most likely because it's just so close to the asteroid belt that it probably gets hit a lot as it's near those asteroids going around their orbits. Okay? So those are the four inner planets. Okay? And again, if we look at the asteroid belt, okay, there's just tons of asteroids just outside of Mars' orbit. And we again make that distinction between the inner and outer planets based on this asteroid belt. So if you notice, the four inner planets, Mars, Earth, Mercury, Venus, are inside the asteroid belt. The other four are going to be outside. Okay? So that brings us to the outer planets. Okay? So the outer planets outside the asteroid belt are, first of all, Jupiter. So Jupiter is the fifth planet from the sun. It's also the largest planet in the solar system. It has 63 moons, which is kind of crazy if you think about it. 63 objects orbiting it. 4 of those moons were discovered by Galileo, which is why they're called the Galilean moons. Those are Europa, Io, Ganymede, and Callisto. Okay, very famous moons. And the surface of Jupiter is not solid. It's actually a gas. The these planets are called gas giants because they're mostly a gas atmosphere, gas planet. So if you crash landed into the surface of Jupiter, your spacecraft would just crash through the surface. So it'd be kind of an interesting phenomenon. Also, Jupiter has this red spot that they call it. I think this is it right here. But it's a very stormy area on the surface of Jupiter that's just caused mostly by all the circulation and gas flow. Okay, then there's Saturn. Good old Saturn, known for its large rings around it. Okay, second largest planet in the solar system. It's made of materials lighter than water, again because it's a gas. So if you could fit Saturn in a lake, it would actually float to the surface. So that's kind of cool. Even as big as it is, it's not very dense. And then also those rings that we're so familiar at seeing, so familiar at associating with Saturn, are just kind of made of rock debris and chunks of ice and other materials that kind of just have gone into these orbits around Saturn. Okay, then there's Uranus. Okay, third largest planet in the solar system. These planets are called the ice giants, Uranus and Neptune, because they have a very solid ice core. It's kind of a weird state because it's not really a solid, but it's not really a gas. It's just because it's so cold and so far away from the sun that we usually associate with ice. So we call them the ice giants. And Uranus has an atmosphere, and it's kind of the blue-green color because it's mostly full of methane. Okay, and then Uranus is interesting because it's the only planet to rotate parallel to its orbit path. So all the other planets, as they circle around the sun, their rotations are perpendicular. They go in a perpendicular direction to their orbit. You can kind of think of them pointing up. But Uranus was probably hit by an asteroid early in its formation and was kind of tilted to the side. And so now it tilts in the direction it's moving. And so it's kind of tilted on its axis, rotates parallel to its orbit path. So that's kind of a cool fact about Uranus. And then we have Neptune. And Neptune is the fourth largest planet, farthest planet from the sun now. And its winds can reach a speed of up to 2,000 kilometers an hour. Okay, or 2,000 kilometers per hour, I should say. So a Formula One car can reach around 250 kilometers per hour. So that's about 10 times faster than a Formula One car. Okay, or if you're not familiar with kilometers, that's about 1,500 miles per hour. So kind of ridiculous, kind of crazy how fast the winds on Neptune are. Okay, so that's the last of our outer planets. So there you go. There's our inner planets, outer planets. If you just look at some characteristics and kind of compare, inner planets are mostly solid rock material, smaller in size, faster orbits, slower rotations, while the outer planets are made out of hydrogen and helium gas, larger in size, slower orbits, and faster rotations. Okay, so they're kind of very distinct on these characteristics, very different types of planets. Okay, so remember the difference between the inner and outer planets. Remember which ones are which. Okay, remember the order for sure. Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune. And then also make sure you remember the planets from largest to smallest as well. Okay, so Jupiter's the largest, then Saturn, then Uranus, then Neptune, then Earth, then Venus, then Mars, then Mercury. Okay, so remember their order in distance and also their order in size. Okay, then on the very edge of our solar system, we have the Kuiper Belt, which is just a bunch of asteroids and dwarf planets and ice chunks and all this kind of leftover material that never really formed in anything. Okay, and so the Kuiper Belt, for this class, we'll pretty much consider it the edge of our solar system. Okay, so let's talk about Pluto. Okay, poor Pluto. It's no longer a planet. Okay, officially became a dwarf planet in 2006, I believe. Okay, so why is Pluto no longer a planet? Okay, before we answer that question, let's think about what makes a planet. Okay, if you think about what makes a planet, it should have these three features. So if you're filling out an application to become a planet, you should have these three things on your resume type thing. Okay, so first of all, if you're a planet, you must independently orbit the sun. Okay, so think about Earth. Earth independently orbits the sun, right? Our moon orbits us, and it also orbits the sun, but it wouldn't orbit the sun if it didn't orbit us. So our moon doesn't count as a planet, right? Our orbit has to be independent. Okay, so Earth's a planet, right? Because it independently orbits the sun. Pluto also does this. It also independently orbits the sun. It's not a moon, it's something else. Okay. The second thing, it must have enough mass so that gravity pulls it into a roughly spherical shape. So think about like asteroids. They're kind of all lumpy and stuff. They don't count as planets because they're not spherical. Okay. Pluto also actually counts on this category. Pluto's mostly round. It's big enough to be spherical in shape. Okay. But this is the third one's the one that really Pluto does not count as a planet. Okay. So in order to be a planet, you must be large enough to dominate your orbit. Okay, or in other words, it must be the largest thing that crosses its orbit. Okay, and this is where Pluto fails. So if you think about the Earth, the only things in our orbit really are us and the moon, but we are way bigger than the moon, right? And so we dominate our orbit. Okay, we're larger than any asteroid, larger than the moon, larger than anything that is in our orbit. So the Earth counts as a planet. But if you look at Pluto, Pluto's orbit has a lot of funky things about it. Okay, first of all, it goes at this strange diagonal. Okay, it crosses through the Kuiper Belt. It crosses the orbit of Neptune. Okay, and so it does not dominate its orbit at all. There are tons of objects out here in the Kuiper Belt that are about the same size as Pluto, and so it has not cleared the path that it has made. And so because of this, Pluto is no longer a planet. Okay, it did not dominate its orbit, and so they now classify it as a dwarf planet. Okay, so there's the answer. Pluto is no longer a planet because it does not dominate its orbit like the other planets do. Okay. All right. So that is everything we covered in week 2 of the solar system. Hopefully that makes sense. And let me know if you have any questions. And thank you for watching.